Hey guys, what is up? It's K-Max. We're back to another video. We'll be talking about the formal charge of sulfate as well as how to draw it. It's a complete walkthrough on the Lewis structure of sulfate, explaining the formal charges as well. First thing you do with any molecular formula is you want to figure out the valence electrons in these elements. So it's going to be 6 in sulfur and 6 in oxygen times 4 here. That's going to be 24, so 6 plus 24 is equal to 30, and this negative 2 means that there's 2 electrons added, so it's going to be 2 added to 30, which is going to be 32. Now we plot this out. So we're going to do S in the middle because, first of all, there's only one of them and 4 O's, and also it's lower in electronegativity, which you always put in the middle. Then we put the O's on the outside. Then we're going to add our electrons. So let's do 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And boom. Okay, so now we check to see if each octet is fulfilled. So let's see, this one, it's 8 perfect, 8 perfect, 8 perfect, 8 perfect, and 8 perfect. So at this point you might think, okay, we're done now. We got the whole thing satisfied. However, you have to think sometimes, especially with the elements sulfur and phosphorus, they always might have a chance of being an expanded octet. So in this case, for things below the period 3, group 3, period 3, you always have to check for the formal charge. So we're going to do that here. So to check the formal charge, you take the valence electrons that it originally has. So we're going to do sulfur first. It's going to be 6, and then minus the current non-bonding electrons, which sulfur has, which is 0, plus the bonding pairs that sulfur has, which is 4. So that's going to be 6 minus 4, which is going to be positive 2. So S here has a positive 2 charge with this formation. Now let's check our oxygen here. So it's going to be as well 6 valence electrons on the outside, minus, this time has 6 non-bonding electrons, plus 1 bonding pair. So that's going to be negative 1. And here when you see a situation like this, you would have to balance this out. It won't be perfect sometimes, but you have to balance these out. So in order to do that, to get this negative 1 charge out of the oxygen, that means it just has to get rid of electrons. And to get rid of this positive, it has to gain electrons. So you see that perfect match there. So when we redraw this, we want to bring these, or any of these electrons of the oxygen, towards a bonding pair with sulfur. Same with these two. We want to bring as a bonding pair towards sulfur. So the new chart is going to look like this. Okay, let's just erase that. Okay, so it's going to be our new bonding pair. And now let's check it again. So see, the sulfur is going to be 6 minus how many non-bonding electrons? 0, plus this time there are 6. So, and that equal to each other will be 0. So that's the charge we're looking for. Now let's test this one as well, the oxygen. So it's going to be 6 minus, this time it's only 4 electrons, non-bonding electrons, plus the 2 bonding pairs that you see here. It's going to equal 0 as well. That's perfect. But you might also think at the same time, hey, how come you tested these, but these also seem to have this old negative 1? And that's the thing. With this, well, you can look back at this and look back at the molecular formula and see there is originally a negative 2 charge. And that is actually where it came from. It came from these two having this negative formal charge and adding up to the molecular formula. So you look back at that, you can see that you're automatically correct because you still have these 2 negative formula charges. So the final diagram would look like this. And obviously there's some, yeah, let me draw this. Obviously there's some bad decaling, but this is what it finally looks out. And this is your formal charge that you have to involve whenever I explained. Whenever you see a period 3 element in your formula, and that's basically how you find sulfate. If you guys enjoyed the video, please make sure to smash the like button and subscribe to the channel. Thank you guys for watching.